Okay, so we're covering a question that is literally a combination of prop theorem, a lot of different theorems, prop theorem, tangent, rules that are applicable to your tangent line, the center, just a lot of different things, different rules and theorems that we've learned. A lot of them literally combined into one question. Okay, so I wouldn't say that this question is difficult. I'll just say that there are a lot of theorems that you have to apply, a lot of things that you have to remember, and it's the fact that you have to view it from different perspectives and angles. But I'm going to show you exactly how easy it is. And by the way, guys, remember, your exams are literally in a few weeks. If you would like to go through the most commonly asked exam questions where I help you go through that step by step, I go through this through my online sessions every single day, guys. If you'd like to join, just send me an email so I can share more information. But other than that, let's get started. 9.2, they tell us that in the diagram we have O is the center. Okay, so the fact that they tell us that O is the center, obviously it rings so many bells in our mind. Okay, so we're reminded of so many different rules we need to identify, and you need to create a list, guys. You need to just write this down on like a piece of paper as you're going through these questions. So we think of identifying radii, we think of identifying a diameter, we think of line from center to midpoint of chord, and we think of angle at center twice as much as angle at circumference. Okay, these are the rules that we think of. So now let's first identify our radius. Now, a radius is a line that stems from your center and ends at the circumference of your circle. So we can clearly see that OE is a radius, and we can also see that OC is a radius. OC stems from the center and it ends at the circumference of the circle. So that means that OE is going to equal to OC. So you just want to go back and label that. OE equals to OC. So we've identified our radius, our radii. So what about a diameter? A diameter is a line that is made up of radii. It's made up of two radii, okay? So a radius is a line that runs through the center, touching both ends of the circle, touching both ends or both sides of the circumference of the circle, okay? So, according to Euclidean rules, Euclidean geometry theorems, diameter will always subtend a 90-degree angle. What does it mean to subtend? Well, it means that it holds a 90-degree angle to the point where it touches the circumference of the circle. So the line or the angle that that diameter holds to the circumference of the circle is going to equal to 90 degrees. So we can clearly see that EC is our diameter. Okay, we can clearly see that EC is our diameter. So we're going to go back. I'm going to take our pencil and trace where exactly EC, where exactly, let's start off with E. You want to start on both ends of the line, trace it to the circumference of the circle. We're going to trace it, trace it, trace it, trace it, trace it. It ends right over here. Do the exact same thing on the other end of the diameter. Trace it to the other part of the circle. It ends over here. So that means A3 plus A2 is equal to 90 degrees. Okay, now for the next part, now we're going to see if the rule that tells us that the line from the center to midpoint of chord, okay? So we need to first look at where the center is. It is at O. So basically, guys, when it comes to this rule, when they speak about the line from center, they're not referring to the radius, okay? This is not the radius, this is just another line segment, okay? So this line segment needs to stem from the center and it needs to touch a chord, and if it touches that chord and if that chord is split into two equal parts, that means that is where the theorem will apply. Or if that line touches a chord and if there's a 90-degree angle between that line and the chord, that's where it's also going to apply, okay? But in this case, we just have radii, guys. We have OE, which is a radius, and we have OC, which is a radius, guys. This rule does not apply over here. It has nothing to do with radii. It only has to do with a line from the center to the chord, to the midpoint of a chord, okay? So that's very important to remember, which does not apply over here. So what about angle at center twice as much as angle at circumference? So when it comes to this rule, guys, you need to be very careful. Angle at center twice as much as angle at circumference. By the way, guys, it's not always this visible, okay? It's not like that rule is only applicable when you kind of see like a bow tie where it looks like a bow tie. No, sometimes it can be a lot more complicated or it's not that clear, okay? So the angle at center twice as much as angle at circumference will only apply when your center is split into several different parts. So if O was split into maybe O1 and O2, then yes, it was going to apply. But in this case, it is not, so it's not going to apply, okay? So now let's continue. They tell us that TAB is a tangent, guys. So we just want to write down a few of the rules that we remember that is directly related to a tangent. What are we thinking of, guys? We're thinking of tan chord. What else are we thinking of? We think of tangent perpendicular to radius. What else are we thinking of? We're thinking of tangents from the same point. Okay. So now let's first start off with tan chord. So you need to identify your tangent and your chord and highlight it. Okay. So we know that TAB is our tangent. Now, which chord is close to TAB, guys? So remember, a chord is just a line that cuts the circle into several different parts. An example of a chord over here would be AE. Okay, AE would be our chord. Okay, you can, and by the way, a chord is not a radius, guys. A chord has to extend from, one point of the circumference of the circle to the next part of the circumference of the circle. It literally just divides your circle into different segments. A segment is like a space, right? So the angle between the chord and that tangent is going to equal to the angle that that chord subtends. So we can clearly see that A4 is between that chord and the tangent. So A4 is going to equal to the angle that AE subtends. AE subtends angle D. Okay. So that means A4. What does subtend mean actually? Let's actually go back and understand what does it mean to subtend. So if you look at a circle, guys, if you have a line, if that line holds an angle to the point where it touches the other part of the circumference, that means it subtends it, it holds it. So this chord over here, the angle that it subtends is going to equal to A4. Now you want to go back and start from both ends of the chord, trace it all the way down to the circumference, it ends here at D. Do the exact same thing to the other end, trace it all the way down to the circumference of the circle, it ends at D again. So A4 will equal to D according to tan chord. Okay, so now where else can we see our tangent line and a chord? So another part of the tangent would be AB and AB and AC. Okay, so the angle between AB and AC is A1. A1 will be equal to the angle that AC subtends. So how do we know if it subtends? You're going to start from C, trace it all the way to the other end of the circumference of the circle. It ends over here. Do the exact same thing to the opposite end. Start at the other end of the chord, trace it all the way to the opposite end of the circumference. They both end here at E2. So we know that E2 is going to equal to A1. Okay, but we have another chord, guys. You need to pay very, very close attention. Another chord that we have over here that is close to the tangent and by the way, a chord has to touch both ends of the circle, like the circumference of the circle. It can't just be like, it floating in the middle, like AH, for instance. No, we're looking at AD. I'm going to highlight AD. Let me just erase this part. Okay, AD and AB. The angles between AD and AB is A2 plus A1. So A2 plus A1 is going to equal to the angle that chord AD subtends. Let's start from one end of the chord. We're going to trace it all the way down to this part. So it ends over here. Do the exact same thing on the other end. Trace it, trace it, trace it, trace it, trace it. It ends right over here. So that means E1 plus E2 equals to A2 plus A1 according to tan chord theorem. Okay, so now let's go on to the next part, right? So now they told us that if it's a point on EA, then we have ED that is parallel to FH. Okay, so ED, ED is parallel to FH, and FH is parallel to TAB. So when we think of parallel lines, guys, there are a few rules that we think of. We think of alternating angles, we think of corresponding angles, and we think of co-interior angles. So let's see if alternating angles applies to this specific question, right? So now let's go on and highlight these lines. I'm going to highlight ED, highlight FH. I'm going to highlight TAB. Okay, so now guys, please remember that you need to look for that diagonal line that connects both of the parallel lines. Okay, so when you're looking at ED and FH, right, those two lines are parallel to one another. Okay, now, we can clearly see that E1 is going to equal to H1. You can clearly see that they are in that alternating position. Okay, so we're just going to go back and mark that off. E1 is equal to H1. Okay, so what else, guys, do we see? Okay, so that is it for alternating angles when it comes to ED and when it comes to ED and FH. So now let's look at corresponding angles. A lot of students forget about corresponding angles, and that can cost you several marks, right? So we have to remember this. So how corresponding angles works is that the angle before one parallel line is going to equal to the angle after the other parallel line, right? Now let's look at ED. So we can take E1 plus E2 as an example. E1 plus E2 is going to equal to F2. F2 is an angle that comes right before FH. Okay, it comes right after FH. And then, yeah, so F2 is going to equal to E1 plus E2 because E1 plus E2 comes right after the other parallel line, which is ED. Okay, then let's look at the other side, guys. H2 is going to equal to angle D because of corresponding. We can see that H2 comes before our one parallel line, which is FH. So H2 is going to equal to D because of corresponding angles. Right. So now let's look at other examples. We have FH that is parallel to TAB. So we're going to do the exact same thing where we're going to identify alternating angles. Remember, guys, we're looking for that diagonal line that connects both our parallel lines. So we can clearly see F2. F2 is going to equal to A4. Then mark that off. F2 is equal to A4 because of alternating. Just look at that Z shape. And by the way, guys, since FH is parallel to TAB, it's parallel to each and every single part of TAB. FH is literally parallel to TA and AB, each and every single part of TAB. So now, if we're focusing on FH and AB specifically, we can see that diagonal line again. We can clearly see that H2 is going to equal to A2 plus A1. Please do not make the mistake of thinking that it's just equal to A2. No, that angle needs to touch the other part of the parallel line, guys. It has to touch it. If we just mark it off as A2, A2 doesn't touch that parallel line. It has to be the entire angle to the point where it touches the parallel line. Okay, it has to touch it. So it's going to be H2 equals to A2 plus A1. Okay, because of alternating angles. Okay, so we've spotted that part. Okay, we have alternating angles. Okay, so now I think we've identified all the alternating angles. Let's go on to corresponding angles. Does corresponding angles apply to this specific question? Okay, so now let's look. Okay, so we can clearly see we have A3 plus A2. We want to focus. Let's look at the angle, guys. We have F1, for instance. F1 comes before FH. F1 will be equal to A2 plus A3 plus A1. Remember, guys, it needs to be the angle that comes before one parallel line equals to the angle that comes after the other parallel line. And please make sure, the reason why we can't just say A2 and A3, no, it's A2 plus A3 plus A1. It has to go all the way to the point where it's touching the parallel line. Very important to remember. Please practice this, okay? Okay, let's make sure to use different colors. It's just that I'm kind of, running out of colors over here. Okay, so now, so now, guys, we have H1 is going to equal to B because of corresponding. So H1 will equal to B because of corresponding. Okay, guys, so now H1 will equal to B because of corresponding. Okay, so now let's continue. We're going to continue on. Let's look for any other part that where corresponding angles applies. No, we can't see anything else. What about cointerior? So I do suggest that you keep cointerior in mind when it comes to calculating the values of numerical values, the certain values for angles, etc. It's very important to remember. Okay, so now let's look at question Okay, so we're just gonna continue. They've given us a ratio. They tell us that AH to HD is 5 to 7. So AH to HD is 5 to 7. So we're gonna label that as 5 to 7. And please remember, guys, this is your ratio. You need to understand what a ratio is. So a ratio basically gives us an idea on how the different parts of a line have been arranged. So they're basically telling us that AH takes up parts of the line and HD takes up 7 parts of the line. It's not the actual length. So to just make sure you don't get confused, just make sure you add like a random value. I'm just going to add an A so that you remember that it's not the actual length, it is just the ratio. Let's look at 9.2.1. Prove that triangle ABC is similar to EBA. So now let's just go back and highlight. I'm going to highlight these triangles. Okay, so I'm sorry, let me just erase this so that you can just see everything clearly. So ABC, ABC, okay, so we're focusing on both the red triangle and the yellow triangle. We have to prove that they are similar to each other. Sorry about all the annotations, guys. I'm just gonna quickly remember we've marked E2 and A1. So I just want to quickly be aware of all the annotations I've made, and then we've marked H1 and that part of there. Okay, cool. So now, guys, we have to prove that these two triangles are similar to each other. How exactly do we do this? Okay, so how you do this is you need to go back and see, just look at the way they've labeled these triangles. Check to see if angle A in ABC equals to angle E in EBA. Angle A in ABC is A1. Does A1 equal to E in EBA? E in EBA is E2. And we've marked them off as being equal to each other because of tan chord. Okay, so that's one mark that we have. A1 equals to E2 because of tan chord theorem. Then we're gonna go back and check, does B in ABC equal to B in EBA? Now what angle is B in EBA? E, by the way, let me just quickly write this. You can clearly see this is B. That's angle B. That's A. Okay. So EBA in triangle EBA is this angle over here. It's this B angle over here. And then B in ABC, sorry, this is C, guys. In ABC would be this angle over here. So it looks like they share the exact same angle, guys. Just look at this. This is an triangle ABA, and then that's triangle ABC. This is where B is. They have that exact same angle in common. You can clearly see they share the exact same vertex. So they have B in common. So automatically B is going to equal to B because they're common. Your reason is going to be common. And then for the next part, guys, the remaining angles, which is C2 in ABC, is automatically going to equal to angle A in EBA, which is remember, EBA. It's this entire this entire angle. EBA is that entire angle. So they're automatically going to equal to each other because that's just a rule. You just need to prove that two angles are equal to each other to prove that they're similar. So your reason is going to be remaining angles of a triangle, and you're going to end it off by saying triangle ABC similar to triangle EBA. Now, the minute you've proved that two triangles are similar to one another, guys, you immediately need to go back and write those ratios down. Okay, so what I've done, I've written out the ratio immediately because I've already proved that they're similar. Just do that, okay? Immediately, if you have proved that two triangles are similar to each other, please just go back and write their ratios down, okay? Then for question 9.2.2, calculate R, the radius of the circle, if AB equals to 5 units and if BC equals to 2 multiplied by R over 3. So AB equals to 5 units, and by the way, this is its actual length. 5 units, my bad, 5 meters. This is its actual length, 5 meters. And equals to BC equals to 2R over 3. So they want us to label the radius as R. What are our radius, guys? OE is a radius, so we're just going to label that as R. And OC is also a radius, so we're going to label that part as R as well. Okay? So now, guys, where do we begin? A lot of students just don't know where to begin, okay? We need to calculate R, but we don't know where to begin. So I want you to draw this hierarchy. I want you to write this down, guys. It's going to be very helpful. Draw like a little hierarchy for yourself. You need to have a hierarchy that tells us what is the most important. The top being the most important rules to follow, and then as we keep going down, as we keep descending from the top of the triangle, the least. Not that I'm saying it's not important, but you just want to create like a little checklist for yourself, a hierarchy to see which rules are the most important to check, right? So at the beginning, you have to see if similar triangles is going to work for you. Similar triangles should be right at the top of your hierarchy, okay? And then after similar triangles, you should be looking at the prop theorem. Okay, prop theorem, midpoint theorem. Prop theorem, the midpoint theorem should be in the exact same column, right? And then the next thing you should be checking is trig. Okay. Yeah, basically that's okay. So that those should be your priority. Okay, now let's see if similar triangles is going to work. So if you've already proved that triangles are similar, just write out the ratios and try and substitute those values in. So now let's start with AB. So AB is 5 meters. So we have a value for AB, it's 5 meters. What about EB? What is EB equal to, guys? EB is this entire line. It's literally OE to OC to CB. So it's R plus R plus 2R over 3, right? Because OE is R, OC is R, and CB is 2R over 3. So just add it. So basically, EB is going to be 2R plus, obviously, because R plus R is 2R, plus 2R over 3. So we know that EB is going to equal to 2R plus 2R over 3. So we have that information. What about BC? We already have BC's value, guys. It is 2R over 3. What about BA? Do we know what BA is? Yes, or AB, it is 5. So that's perfect, guys. And what about AC? Please remember that you need to choose between two fractions. You can't use all three fractions, okay? So now let's look at AC. AC, do we know what AC is? No, we have no idea what AC's value is. It doesn't even have like a variable. What about EA? Do we know what EA is? Do we have any idea about what it is? No, we do not. So yeah, we're definitely not going to use that fraction. We're just going to use these two. So what you're going to do is you're just going to substitute everything in just like I showed you previously. Okay, cross multiply, guys. So the 5 will be multiplied with the 5, giving us 25. Then please remember to place it outside of brackets. 2R over 3 multiplied by this expression, leave it outside of the brackets. Foil the fraction in brackets. Please be very careful with this one. 2R over 3 multiplied by 2R gives us 4R squared over 3. Please remember how not trigonometry, please remember your algebraic, not even algebraic laws. This is just basic fractions, okay? 2R multiplied by 2R is 4R squared. But if you're multiplying a fraction with another variable, remember, nothing really, happens to the denominator, because, the denominator of 2R is 1. So 3 multiplied by 1 is 3. 2R multiplied by 2R is 4R squared. 2R multiplied by 2R squared. 2R multiplied by 2R is 4R squared. 3 multiplied by 3 is 9. We have our answer. Okay, so guys, now what do we do? So what we have to do is we have to add 4R squared over 3 to 4R squared over 9. But we have an issue. They need to, if we're adding two fractions, their denominators need to be the same. So we're just going to change this fraction's denominator so that it's 9. The only way we can do that is if we multiply both the numerator and the denominator with 3. 4R squared multiplied by 3 is going to give us an answer of 12R squared, and then 3 multiplied by 3 is 9. Okay, so then we're going to have 12R squared over 9 plus, and then we're just going to be left with the 4R squared over 9. Now we can add them, and that's going to give us an answer of 16R squared over 9. And then what you want to do is, guys, you just want to cross multiply. Okay, so you just want to go back and cross multiply. And once you cross multiply, multiplied by 9 is 225. Okay, and then the 16R squared is going to go over onto the other side. What you're going to do is you're going to take the 16, you're going to divide the 16 with the 225, and then you're just going to square root it, and then you're going to get an answer of 15 over 5. And that's exactly how you'd solve for it, right? So you just need to follow those steps, guys. You really need to practice. Okay, so I don't want to make this video too long. We're going to be finishing off with the next questions in the next video, guys. Please make sure just to watch it, repeat, redo, guys. You won't get better if you don't repeat and practice. Okay, but as for now, I will see you in the next video.